Hi, let's continue with the next section, 5.4 parabolas. So in the past, we dealt with parabolas where the term being squared was the x. If it was positive, our parabola opened up, and if we had a negative leading coefficient, then our parabola opened down. So what we will discover in this next section is when a parabola opens left, or maybe when it opens right. So we're going to add that to our list. Our objectives for this section is 1, the standard form of the equation of a parabola, 2, graphing parabolas, and 3, finding equation of parabolas. Parabola equations. Previously in this course, we studied parabolic graphs as the graphs of quadratic functions. As the graph of functions, the vertical line tested our discussion to parabolas that opened up or down. In this section, we'll be using a geometric definition while discussing parabolas, resulting in a general definition that allows for a parabola to open in any direction, even diagonally. However, we will limit our discussion to parabolas that open left, right, up, and down. The definition of a parabola is a set of all points on a fixed equidistant from a fixed line called a directrix, and a fixed point on the line called the focus. So here we see our graph. We have our vertex like before. An introduction to this new section is our focus point and our line that's called the directrix. As the example above depicts, we will study parabolas using the vertex, directrix, and focus. However, despite the general definition, which has no limitation on directrix, we will limit the directrix to either a vertical or horizontal line, resulting in parabolas that can open from 4 directions, left, right, up, or down. The list of components involved with the parabola will include the following: the directrix, the focus, and the vertex. Again, from our text, we can derive the following standard equations of parabola. So the first one is y minus k squared equals 4p times h minus k, and that opens left to right. We know it opens left to right because we see the one that's being squared. The one that's being squared is the y. Our second example, we have x minus h squared equals 4p times y minus k, which opens up or down. So like before, we would see y equals ax squared minus bx plus c. Our square term was the x. So if the x is being squared, it's more of a traditional looking parabola, meaning it opens up or down. Graphing parabolas. We will focus our initial discussion on graphing parabolas with determining the vertex and the directions in which a given parabola opens. First, when determining a vertex, make sure that the x-coordinate is always a value in standard equation, that is, associated with the variable x, while the y-coordinate is always the value associated with the variable y. Secondly, the direction in which a parabola opens depends on 2 characteristics. We must consider which variable is squared and which the value of p is positive or negative. If we recall our previous study of quadratic equations, the variable squared was x, and the parabola opened up or down. Therefore, equations with x squared will continue to be parabolas that open up or down. Equation with y squared will be the parabolas that open left or right. Then, considering the sign of the value p, we have the following possibilities. So this p is this number here that's next to the non-squared term. If it's a negative, it'll open towards the negative side. So if it's up and down, if my my 4p is negative, it'll open down. If my y is squared and my 4p is negative, it'll open left. so down and left. If it's positive, they'll open towards the positive direction, meaning up and or maybe right. Example 1. Determine the vertex and direction of each of the following parabolas. So to begin, give yourself a mental note. Which way should it be opening in? Well, because my y is squared, I'm left for it to open either left or right. Because the number on the other side is negative, my option would make it the negative option, so left. It would not be opening right. All right. The equation can be considered in standard form as, so therefore our vertex would be 0, 0, because we're not subtracting anything within parentheses. And then we need to figure out that p-value. We always take that number from the sides not being squared and divide it by 4. Because from our standard formula, it's 4p equals that number. In this case, that number is negative 8. So we go ahead and solve. Divide by 4, we divide by 4, and get p is negative 2. P is negative 2, so along the variable y as the squared variable, the graph opens left. And we knew that because that sign was negative. Example B. So just like before, your h is attached to your x, and your k is attached to your y, so keep that in mind. So I have x squared equals 12 minus y, 12 times y minus 1. So therefore, my h and k are left to be negative 2, comma, positive 1. That's our vertex. All right, we see that we have a squared term that's the x. So my options are up and down. The number on the other side is positive, therefore our graph will open up. So we have the factor of 12. Since our formula is 4p, we get a p of positive 3. So along with the variable x as a squared variable, the graph opens to the up, or just up. C, our squared term is the y. So our graph is left to open left or right. Our other term on the other side is positive, so it will open to the right. My center, I take a look at my numbers h and k. Remember, h is with the x, k is with the y. And we switch those signs. So our center would be negative 2, comma, positive 3. And as we said, our graph opens to the right. In general, using two standard forms of the equation of the parabola, those are two standard forms, and they let us know whether it opens up, down, left, or right. But we're going to use little pieces of it to help us figure out what our final graph should look like. So these are these pieces. First, we want to determine the vertex, which is at peak point. So if you draw a parabola, it's at peak point on your parabola. 2, determine the p-value and the direction the parabola opens. That p-value will serve two purposes. This will help us find the directrix and the vertex. And that's step 3. Determine the focus and the directrix, both a distance p from the vertex. Determine the width of the parabola and draw the curve. The width will be found with the formula 2 times p. All right, let's go ahead with example 1. So from example 1, we determined that our vertex is 0, 0, and that p-value was negative 2. Again, that comes from 4p, and that value is negative 8. So we're left to work that out. Divide by 4, divide by 4. P is negative 8 divided by 4, negative 2, just as we have. Okay, so our vertex is 0, 0. The focus will be a distance from the absolute value of p. And the reason we use absolute values is because it's a distance. We're just going to take that number. It doesn't matter if it's positive or negative. We're just going to take that number and move it to Well, I can't say left or right because it can also move up and down. So you're going to move it to the inside of the parabola and the other side of the parabola. I think that's a better way of saying it. So we know our parabola is going to open to the left because my y is squared and my other number is negative. So I like to mentally draw just a sketch of which way it's going to open along with your vertex. So we have a vertex at 0, 0, and I know it's going to open to the left. Now we're going to take our p-value, which was -2, and we want the distance of it. So just a number, not the sign. And we're going to move that number p inside. So it was 2, 1, 2, and then away, 1, 2. When you move inside, that's going to give you your focus point. When you move to away from your parabola, that's going to give you your directrix. So in this case, it always opens, so it's not going through the parabola. If it were to go through, that would be your axis of symmetry. So this is not your axis of symmetry, it's your directrix. It opens along next to your parabola. So if my parabola opens left or right, my directrix is forced to be up and down. So it will be the line x equals, and it's on the point 2, so x equals 2. All right, we're going to use that p-value to finish off my graph, because from this highlighted point that we drew, I don't know how far out it opens. I don't know if it's skinnier. I don't know what it does. I just know the direction it opens. So we're going to use that value p to figure out, hey, what kind of graph do I have? Which way does it open? Or how far out? Oh, how far does it open? Knowing the graph opens to left and right, the final characteristic is determined to the width of the parabola. For the width, we define the segment called the latus rectum, and it's a line segment whose endpoints are on the parabola from the focus. We find the 2 points of distance 2 times p, so that's your formula. And you're going to open it along your vertex, because that's what help that along your focus, because that will help you figure out where your endpoints are. And you'll move them whichever way your parabola needs to open up. So in this case, it'll be up and down. So from our focus point of -2, we're going to add 2 times p. My p was 2, so we get 4. I'm going to take my focus and I'm going to move up 4, 1, 2, 3, 4, and down 4, 1, 2, 3, 4. And that will help you determine how far out to open, because that will be that special point. However, you need to be more careful because it does matter where that falls. It can't just be a simple, well, it can be if you're using graph paper, it's easier to keep track of, but we need to find that special point. So if we add and subtract 4 to my x coordinate, we get the points -2 and -2, 4, and -2, -4. The endpoints of the latus rectum. So we're going to we added 4 and we subtracted 4 from our vertex, which was 0, 0, to our y coordinate. I believe I said x coordinate by mistake at first. So that would be the endpoints of the latus rectum. Notice that these points are 4 units from the focus and 4 units from the directrix, satisfying the definition of a parabola. So that we have this point given. So first, you want to find your vertex. Remember, it's always h, k. And for both of those, remember to change the sign from your formula. Next, we're going to use that value 4 times p to find p. That'll be the other number on the other side of the equation. And P is going to be away and inside. So whichever way your parabola opens, one's going to be inside and one's going to be away. From there, we're left to determine, with the formula 2 times P, the distance of your endpoints of your parabola. They're not really your endpoints. Maybe we can say extra points, that'd be more proper to say. And they line up with your focus point. So from your focus point, whatever that P was, that's going to help you finish drawing your parabola along your vertex and those endpoints. All right, let's do this next example. So let's first determine which way our parabola should open. So we see that my x is squared, so that means it should open traditionally, meaning up or down. My next number is positive, so it's forced to open up. Cool. Now we just need to find a couple of more pieces to figure out what my graph should look like. I need to find, remember, your vertex, directrix, and your endpoints. All right, let's move forward. We determined the vertex is -2, 1. Remember, it's h, k. Your h is always with your x, your k is always with your y, and we change the signs, thus -2 and +1. All right, next, we need to determine that p. So we need to take that number, and remember, it's always 4p. So we just need to divide that number by 4, in other words, just divide it by 4. So we get a p of 3. All right, that p number is helpful because that's going to help us find our directrix and our focus point. So if you want to, on your little sketch that's helping you remember if it's up or down, you're going to take P inside and P away. So we're going to have a horizontal line, y equals. So if we move up, we're going to add it to our y. So here we see we're going to add to our y 3, and we're going to subtract to give us a point along. Well, we don't have to subtract. We can just count along. All right, so here we have our focus point that's within our parabola, and here we have our directrix. And we got that from counting 3 points. So let me zoom in, from this point we counted 1, 2, 3, and we're here. That's at -2. So I have the horizontal line y equals -2. From my vertex, because I know my graph is going to open up, I'm going to count 3 inside because 3 is the p-value. So I have 1, 2, 3. And that gives you your focus point. So that's the point 2, 4, 2, 4. Next, it's to find out those points that line up with your focus point. So they're going to line up with the focus point, and that will help you determine how far out or how skinny your graph, your parabola will look like. And it's just a sketch because I always get caught up in which way I count my p-value, inside, out. I know it's inside, outside, but it takes a sketch for me to figure out what we're working with. All right, our formula is 2p. Our p was 3, so 2 times 3 is 6. I'm going to move 6 units along my focus to figure out how far out my parabola opens, right? So I know I need to find these points. All right, so I'm going to move 6 points left and right, so we're going to add that along our x. So my x minus 6 and my x plus 6, or you can just count using your grid, will give us the points -4, -8, 4, and 4, 4. So you can add to your corner points, or you can just count using your grid, right? You would count very carefully to get 6 units this way and 6 units that way. You can also count if you don't want to add and subtract. So if you're moving along left and right, you're going to add and subtract to your x. If you're moving up or down, you're going to add and subtract to your y. And hopefully this is something that you have caught on from the chapter, because it seems like we're always adding and subtracting left and right to figure out our focus points, our box for our hyperbola, for ellipses, finding those focus points in the foci. Example 2. We want to graph the parabola, label the vertex, focus points, directrix, and endpoints of the lattice rectum. The problem here is it's not in standard form, right? For a standard form, we like something squared equals some number with more parentheses. And we're lacking that parentheses squared. Well, let's go ahead and rewrite it. First, we must recognize the equation y squared plus 8y plus 8 equals 0 can be written in the form of our equation. First, we need to isolate that squared term. In this case, the squared term is x squared. So let's get x squared by itself, along with any other x. In this case, we only had one x. You want to move everything else that isn't your squared variable on the other side. Okay, so on the other side, we see that I'm able to factor a common factor. Namely, we want to be able to get that y, that variable by itself. So we're going to divide whatever coefficient it may have. So we're forced to divide -8. Once we factor -8 and we divide -8 to both terms, we're left with -8 times y plus 1. On the other side, I just had an x squared. So if I were to have x squared plus x, another x, then I would have to complete the square. But we don't have that case. We'll see it soon enough. All right, so here now we have an equation in that standard form. Now we can pick out those pieces. We can find out what 4p is, or just divide by 4. We're able to figure out if my parabola opens up, down, left, or right. In this case, it opens up or down, but because we have a negative, it opens down. And we're able to also pick out our vertex, right? Our vertex is always h comma k. My h is 0, my k is -1. So my vertex is 0 comma -1. Again, this is because my k is with my y and my h is with my x, but I don't have, I said h, but I don't have a number being added or subtracted to my x, so it's forced to be 0. All right, now we need to divide -8 by 4 by that formula 4p, which essentially only divides it by 4. So we get a p of -2. We just want the value of it. We really determined that it opens down. So this p-value, my parabola opens down. So this p-value is going to help me move 2p, that value p is 2, away. So that's going to give me my directrix. And that p-value, one of them is going to move inside. And that's going to be my focus point. And that's just a sketch, so I can have a mental idea of what's going on. All right, so in the same direction from the vertex, the parabola, the focus will be 2 units downward located at, since it's moving down, we're adding it to our, I think that should be our y. Yeah, I think that was a mistake right there. -2 comma 1 is not a point here. So from our vertex, we're going to move 2 units inside, 1, 2, and you get 0 comma -3. That's your focus. Then we're going to move 2 units away. 1, 2. 1, 2. And that's your directrix. And it opens not going through your parabola. I don't know if that is a good wording. So it'll be a horizontal line, and this is at 1. So horizontal line at 1, y equals 1. Now we're left to find the endpoints of my parabola. So I need to find these points. How do I find those points? Those points are 2 times p. We said p was 2, right? We said p was 2. So I have 2 times my p of 2. We're left with 4. So I'm going to move 4 units this way and 4 units that way. So you can count them off. 1, 2, 3, 4. You're left with 4, negative 3. And then for the other way, you're left with negative 4, comma, negative 3. Example 3. Graph the parabola 2y squared minus 16x minus 8y plus 40 equals 0, labeling the vertex, focus, directrix, and endpoints of the lattice rectum. So again, this problem is not in standard form. So we know we need to go through the trouble of writing it in standard form. So in this case, see here this y is squared? We want, since the y is squared, I want all the y's on one side and everything else on the other side. So first, we recognize that needs to be written in standard form. Because my y is squared, I want my y on my left-hand side along with any other y's. And everything else I want on the other side of my equal sign. So we subtract, or we add 16x, and we subtract 20 as well, so that we are here. All right, now we want to complete the square. I want to have something in parentheses squared, right? We want just one copy of y. So we need to complete the square with that formula, b divided by 2 squared. My b is negative 4. Negative 4 divided by 2, we have this here. We get negative 2, and we have to square that, which gives us 4. So we're going to add 4 to both sides. So now we're here. Now we're able to complete the square. So this factors to be y minus 2 squared. And the other side we have 16x minus 16. Now, almost done. We want that x to be by itself. So we have to factor out that 16. So we're left with 16 times x minus 1 on one side of our equation. And this is what we wanted. This is our standard form. All right, now I'm able to pick out if it opens left, right, up, or down. Because my y is squared, I know it's left to open left or right. Because the other number is positive, it opens to the right. Okay, so my vertex is always h comma k. Your h is always with your x. Your k is always with your y. So my vertex is positive 1 and positive 2. Now that p-value, we divide that number by 4. So we get a p of 4. 16 divided by 4 is 4. So we know my parabola opens to the right, and I'm going to move 4 inside and 4 away. So give yourself time to draw it carefully on a grid, on graph paper. If you're using line paper, that's okay. Just be careful to use tick marks and try to be as careful as possible. So the focus will be 4 units to the right of the vertex. So we're going to add 4 to our x. So that point will be 5, 2. That's 5, 2. Now if we move away from our center to the other direction, we're left at negative 3, which gives us this directrix. All right, lastly, to figure out those points, I multiply 2 times p, which is 8. So I'm going to move 8 units from the focus. So we have this parabola as our answer. So notice we have our vertex, and then our p was 4, so we counted 4 inside and 4 away. That gave us our focus and our directrix. Now we use that formula 2 times p, which resulted in 2 times 4, which is 8. So we moved 8 points along our focus to create those endpoints of our parabola. Lastly, finding the equation of a parabola. As with every section in this chapter, the final topic in the section will contain questions that ask for the equation of a graph that has specific qualities. Example 4. Find the standard form of the equation of a parabola that has the vertex 3, -1 and a focus of 0, 1. Alright, so this tells a lot because I know from the vertex to the focus, that's distance p. So that's telling you what p is. So I have this graph, and we're told the vertex, and we were also told the focus. So I know this distance that exists between them is forced to be that p-value. And if we look closely in our number line, or if we notice the distance from, we're moving left to right, so along our x, the distance from 0 to 3 is 3 units. Lets me know that p is equal to 3. Not just that, we also know our, I keep saying center, but for a parabola it's called the vertex. And we know the vertex. That's an important key feature of our standard equation. We also know the direction our parabola opens. It opens to the left. So this tells me that my p-value is going to be negative. Since the parabola opens left, we know the equation will be of the form with a y squared. And because it opens to the left, I know I will have a negative number here. We know our vertex, h, k, so this tells me that I have y plus 1 squared equals 4p times x minus 3. We got that from our vertex. Lastly, we know that p, distance, that focus is 3 units. Since the parabola opens to the left, p has to be negative 3. So our equation is 4 times 3 to help us find that p-value. So we have this final answer for our equation. So we got that number from 4 times p, and these were our vertex, k and h. It's always h, k, but remember h is always with your x and k is always with your y. And you change the signs. Next question. Find the standard form of the equation of the parabola that has a directrix of y equals -5 and a focus at -2, -1. So the fact that we have a directrix that's a horizontal line, it's telling us that our parabola has to open either up or down. How do we know? Well, it depends on the position of the focus. So we see that the focus right here is -2, 1. And if this is our directrix, our parabola needs to be between that. And it also needs to not go through or touch the directrix. So our parabola is forced to open up. So I know my parabola opens up. Now I know that that middle point from our focus, from the point along our directrix, will produce that focus point. Not focus point, that vertex. So if we create, so this is where we have to be clever. If we create this special point along my directrix, I know my y will be -5, and my x has to line up with my focus, which would be -2. So that's a special point along my directrix. So since a parabola opens up, we know the equation must be in this form, meaning your x is squared. Know that the vertex is the midpoint from the vertical segment of the directrix to the focus. We find the vertex is -2, 3. So we have to find the midpoint between these 2 points. That'll produce that vertex point. Remember, your midpoint is your x's divided by 2 and your y's divided by 2. One of them has to be a 2. You just take both of your x's and both of your y's and divide it by 2. So we have x1, y1, x2, y2. Let's do that work since we don't have it in our text. x1 is -2 plus x2 is -2. We're going to divide that by 0. Our next coordinate will be y1, which is -5, plus y2, -1 divided by 2. So -2 plus 2, -2, we get -4 divided by 2. And -5 plus -1, we get -6 divided by 2. We get -2 and -3. And that is your vertex. -2, -3. Just as our text says. Lastly, we need to find that p number. So we can just count. From our vertex, we go 1, 2, 2 points to get to our focus. And we can double check by counting from our directrix. 1, 2. So it checks out. My p is forced to be 2. Knowing that the vertex is the midpoint of the vertical segment from the directrix to the focus, we can find the vertex is -2, -3. We did that. Lastly, the distance from the vertex to the focus is 2 units. We just counted from our image. And since the parabola opens up and p equals +2, then we have this equation. So we have our vertex is always h, k, h and k. Remember to change your signs. And lastly, your p, you multiply it by 4. So 4 times 2, we get 8. And this is our answer. How do you know when this one's negative? Well, it's negative if it opens left or opens down. In this case, it opened up, so it was forced to be positive. So we have a +8. All right, that's it for this section. If you have any questions, please post your questions on our discussion board or you can email me. Thank you.